Hi guys, for this video I am going to solve a circuit using the superposition theorem. Here is the sample circuit consisting of a 50 volts voltage source and an independent current source of 6 amperes. Connected to the circuit are 3 resistors: R1, R2, and R3. The values of the resistor are 10 ohms, 2 ohms and 5 ohms. In solving the circuit using the superposition theorem, we have to calculate the current flowing to the R2 using one source at a time. Meaning, if we will use the 50-volt source, we will open the current source and solve the current at R2. And if we will use the 6-ampere independent current source, we short the voltage source and solve for the current at R2. Right after we solve 2 currents flowing to R3 using 2 sources, we will add it algebraically. Okay, we go now to the circuit. First we are going to use the 50-volt source, so we have to open the current source. So as you can see guys, if we open the current source there will be no current flowing to R3. Meaning, R1 and R2 are connected in series with the 50-volt source. We designate the current flowing at R2 with respect to 50-volt source as IL'. To solve for IL', V over the total resistance of R1 and R2, since R3 is disregarded due to an open circuit. Using the values, we have 50 over 10 plus 2. Simplifying 50 over 12, which result in 4.17 amperes. IL' is 4.17 amperes. The direction of the current is from this node going to the ground. Next guys, solve for the circuit using the independent current source 6 amperes. To do that, short the 50-volt source. And as you can see, it is a simple current divider formula. R1 and R2 are in parallel connection. The parallel connection of R1 and R2 is connected in series with R3 and current source. As you inspect guys, the current flowing to the R3 is 6 amperes since the current source is in series with this resistor. But for R2 and R1, we can solve it using the current divider formula. We will designate current flowing to R2 with respect to the independent current source as IL'. To solve for IL', we will use the current divider formula, which is total current I, multiplied by total resistance, RT, divided by the resistor R2. To solve for RT, it is the product over the sum of R1 and R2. So we have I over R2, times R1 times R2, all over R1 plus R2. As you can see, R2 will be cancelled out. IL' is equal to I times R1 all over R1 plus R2. Plugging in the values. 6 times 10 all over 10 plus 2. Simplifying, 60 over 12, which will result in 5 amperes. The direction of this current is the same with the IL'. Meaning, IL is equal to IL' plus IL'. Using the values, 4.17 amperes plus 5 amperes is equal to 9.17 amperes. And to solve for the voltage at R2, designated as VL, will be equal to IL times R2. So 9.17 amperes times 2 will be equal to 18.34 volts. And that's it. That's how we solve a circuit using superposition theorem.